Alrighty, guys, let's go ahead and look at some of these momentum problems. So the first one we have says Jose Quintana of the White Sox pitches to Anthony Rizzo a fastball in the ninth inning of a game. The 0.15 kilogram baseball is initially thrown with a velocity of negative 28.5 meters per second. The bat is swung with a velocity of 22.5 meters per second. I'm going to actually put that in a different color because we're talking about the bat now. After the collision, the bat follows through with a velocity of 9 meters per second, and the bat has a mass of 0.7 kilograms. The ball is moving with a velocity of 34.5 meters per second after Rizzo swings. So these momentum problems are best when we set up this table that we have down here, where we have our two objects, the mass before, the mass after, the velocity before, the velocity after, and then the collision or the momentum of that object before the collision and the momentum of that object after the collision, as well as the total momentum of the system before and the system after. So let's start off with this bottom question. What type of collision is taking place here? Well, a baseball and a bat are hitting each other and they're bouncing off each other. Since they're bouncing, that's going to be an elastic collision. So elastic, meaning that they're bouncing off of each other, that's the type of collision that we're looking at. Now, let's go ahead and start filling in these boxes. So the mass of the baseball is 0.15. So I'm going to go ahead and write that right here. The mass of the baseball is the same before as it is after, because the baseball is not falling apart. It's not having anything added to it. It's just going to be the same. Next, let's do the mass of the bat. Well, the mass of the bat is 0.7. Again, the bat is not falling apart, or the bat is not having anything stuck in it after it hits it. So it's going to have the same mass before as it does after. Next, let's see what we're given. It tells us that the baseball is initially thrown with a velocity of negative 28.5. So the initial velocity for the baseball is negative 28.5. The bat is swung with a velocity of 22.5 meters per second. So that's the initial velocity of the bat. Notice that the ball is negative and the bat's positive, meaning that they're going towards each other. Because they're moving in opposite directions, that means that they will eventually collide. Now, if we keep moving along, it says after the collision, the bat follows through with a velocity of 9 meters per second. So the bat's velocity is 9 after. And then it also says the ball is now moving with positive 34.5. So that's interesting, meaning that the ball is now moving in the direction that the bat was moving, which would make sense, and we'd expect that in baseball, because if a person is swinging at a ball, so if we have our bat here and it's swinging at this ball, we would expect the ball to move in this direction and the bat to follow through behind it in the same direction. Now that we have all these numbers in, it's really just simple algebra to figure out our final answer. We know that momentum is equal to mass times velocity. This is our mass, this is our velocity, this is our momentum. So in order to get that, we're just going to multiply these things across. So let's start with the baseball here. So the baseball has a mass of 0.15 and it has a velocity of negative 28.5. If we multiply those two things together, we find out the momentum of the baseball is negative 4.28. And then if we do the same thing to figure out the momentum of the bat, we get the mass of the bat, which is 0.7, times the velocity of the bat, which is 22.5, which gives us a momentum of 15.75. So the total momentum here is going to be these two things added together. So the total is the momentum of the baseball before the collision plus the momentum of the bat before the collision. So if we do that, we find out that the total momentum before, B4, is equal to negative 4.28 plus 15.75. And if I plug those two things into my calculator, I end up with a total momentum of 11.47. What's interesting is that the total momentum before should be the same as the total momentum after. So these two things are going to be exactly the same, which is what we would expect because we know that momentum is always conserved. Now we just need to go ahead and figure out what these two things are over here. And again, we've been given so much data that this should actually be pretty easy to solve for, and we can do that just like we did before. So the momentum of the baseball after the collision is equal to the mass, which is 0.15, times the velocity after, which is 34.5. If we multiply those two things together, we find out that our momentum of the baseball after the collision should be 5.18. Next, we're going to go ahead and solve for the momentum of the bat after the collision. And it's just the same thing. It's the mass of the bat, which is 0.7, times the velocity of the bat, which is 9. So if we multiply those two things together, we end up with 6.3. And we can see that if we add these two things up, we get 11.47. And if we add these two things up, we get 11.48, which is super close. It's just a rounding error on our part, but basically the exact same answer.